Good morning, students. Today we will discuss about recursion using Python. So, the first and foremost we have to understand is what is recursion. A function call itself is called recursion upon satisfying the two conditions. One is the problem must be in recursive form. The second is there must be a base case or the termination condition is exist to ensure the program can finish its execution in finite number of steps. Now let us see with the example. So let us see the simple example. What I am going to do here is I will take the multiplication as an example for it. First we will see the multiplication with the normal function, then we will see the multiplication with the recursion. Now, if it is a normal, let me open my IDLE environment. File, new. So, since here I want to multiply the two numbers, so let me write the function. We all aware that the function must start with the keyword def. Now I am having the function multiplication a comma b, then I can simply write print a into b, print a into b. Now I will call the function. I will call the function multiplication. So for which I am going to take two arguments. Enter a, int enter b. Now I will call the function multiplication a comma b, a comma b. Let me save this. Now let me run it. Now the same one we want to implement with the help of the what? Recursion. With the help of the what? Recursion. Now when we want to implement the same thing with the help of the recursion, first we have to understand the basic fundamentals here. Whatever the problem you have taken, the problem must support the recursive nature. That means whatever the operation you want to do, that operation you have to perform iteratively, and there must be a base case or the termination condition is existed to ensure that the program is finish its execution in finite number of steps. Now So let us take the same one. Let us assume that the multiplication of the two numbers, I want to multiply 5 into 4. 5 into 4. So 5 into 4 means what I can do here is I can add the 5 for 4 times so that I will get 20. So what is the operation I am performing here? Repetitively addition. How many times? 4 times. So addition, the repetitive addition will ensure me that the problem is in the recursive nature, and whatever the operation I am doing, that I am doing in finite number of steps, that is what 4 times only I am performing this operation, right? So that means problem in recursive nature is exist and finite number of steps here also exist. Both the conditions are satisfied. Now let us discuss in detail. Now multiplication of 5 comma 4. Multiplication of 5 comma 4. This I can write as 5 plus multiplication of 5 comma 3. 5 comma. So the same, this multiplication of 5 comma 3 I can write it as 5 plus multiplication of 2. Now this one I can write it as what? 5 plus multiplication of 5 comma 1. So 5 ones are, we are aware that 5 ones are, it is what? 5. 5 ones are, it is what? 5. Now so I am substituting the value here. So whatever the function I am calling, what I am trying to do is so here this one will be replaced by what? 5. So when it is replaced by 5, the multiplication of 5 comma 2 is replaced by what? 10. Now since the multiplication of 5 comma 2 is 10, here it will comes, then this becomes 10, then the 5 plus multiplication of 2, and this will gives what? 15. Then multiplication of 5 comma 3 is what? 15. Then this multiplication of 5 comma 3 function is replaced by 15. Then this 5 plus 15 gives the what? 20. So at the last we got 20. Now here the thing we have to understood is, here the function is called itself. The function is called itself. Yes, the function is calling itself is okay, and there is also a termination condition is also base case is also exist. Whenever the multiplier is reached to 1, it start returning the value, thereby the function values are substituted in last in first out manner, and at the last we got the answer. Now when we take multiplication of 5 comma 4, this 5 comma 4 will cause the what? 5 comma 3. This 5 comma 3, this 5 comma 3 calls the what? 5 comma 2. This 5 comma 2 calls the what? 5 comma 1. So here this 5 comma 1 is first replaced by what? 5. Then 5 comma 2 is replaced by 10. 5 comma 3 is replaced by what? 15. 5 comma 4 is replaced by what? 20. Right? So this is how it is going to operate. Now let us start writing the code. Now def multiplication a comma b, a comma b. Now here If one of the value is 0, either A or B is 0, our result is what? Then if A equal to 0 or B equal to 0, then what it will return? It will return 0. It will return 0. Then if one of the value is 1, if one of the value is 1, then automatically the other value will be the result. The other value will be the what? Result. Then return A. Else what I told you, A into B, then we can write it as a what? A plus multiplication of B minus 1. Then return A plus multiplication of A comma B minus 1. A comma B minus 1. This is what the function definition. Now I am going to call the function. Call the function. Right. Now when I am calling the function, so first I have to accept the values, two values. Now A equal to int of input, enter A, B equal to int of input, enter B. Then C equal to multiplication of A comma B. Then I am going to print the what? This is what the program. Now here, sir, what are the base cases are existed? So this is the one base case, and this is the another base case, and this is the third one. Three base cases are exist. If any one of the base case is satisfied, it is going to return the value. And where is the problem is in recursive form. See, the same function is calling multiple times. Right? Now run module 10 5. See, we got 15. We got 50. 10 5 is what? 50. 10 5 is what? 50. That is what. Clear? So this is what is called the recursion, the multiplication of the two numbers. Multiplication of the two numbers. Now let us try one more example. So let us take factorial. Let us take factorial. Factorial of the number using recursion. Now, so generally first we will understood what is this factorial. So if we take the 0 factorial, we are aware that 0 factorial is 1. So if we take the 1 factorial means what? 1. So 2 factorial, we can write it as what? 2 into 1 factorial. Similarly, we can write 3 factorial equal to 3 into 2 factorial. Similarly, if you take 4 factorial, 4 we can write as 4 into 3 factorial. Now, you understood that? N factorial means we can write it as n into n minus 1 factorial. Now, if you understood that, the same function is calling repetitively. If you take factorial as a function, so the same function is calling repeatedly. And what can be the base case we can set here? Whenever whatever the number you have taken, if the n equal to 0, we can written as a what? 1. If n equal to 0, we can written as a what? 1. We can written as a what? 1. So else we can write it as a what? N into, we can write fact of n minus This is the simple code, right? So this is the base case, and this is the what? Problem is in recursive form. The problem is in what? Recursive form. The problem is in what? Recursive form. Now let us start writing the code. Def fact of A. If A equal to 0, I will return 1. 0 factorial is what? Else I will write what? Return A into fact of A minus 1. Fact of A minus 1. Now let me call the function. Now I am going to call the function. Now, so let me accept the value A equal to int of input, enter A, then I have to call this function, right? So B equal to fact of 10, then after I am printing the B. Now run module. Yeah, here, sorry, 15 factorial is what? This. So this statement I know what to write. Here I have to pass the what? A. Here I have to pass the what? A. Now run module. Let us print 5 factorial. 5 factorial is what? 120. 5 factorial is what? 120. So this is what the another example for the recursion, right? Now let us discuss one more example for the recursion, Fibonacci series. So let me save it as Fibo. Now we all aware that the Fibonacci series, the first element is 0, the next element is 1, and the third element is sum of the previous two terms. So that means if the first term is what? 0, second term is what? 1, and the third term is what? F1 plus F2. If you take nth term, Fn equal to Fn minus 2 plus Fn minus 1. This is a one pure recurrence relation where the current term is the what? Combination of the previous two terms. Right. Now let us write the code for it. Now we all understood that if n is greater than 2, that means 3, then it has to be what? The combination of the previous two terms. Now, so let us start writing the code. Def Fibo n, if n equal to 1 or n equal to second term, then if n equal to 1, then what we have to return? First term is what? Return 0, ELIF. If n is the second term, what we have to return? The second term value is always fixed, that is what? 1. Else what we have to return? Return Fibo of n minus 2 plus Fibo of n minus 1. Done. Now I am going to call the function. Call function. Now let us print 10th value in the Fibonacci series. Now a equal to int of input, enter a, then print Fibo of 10. Fibo of 10. So let us see what is the 10th Fibonacci number. Yeah. 34. Now here you have to pass the what? Yeah. Now run it for some other. So I want to print the third term. The third term is what? The third term is what? 1. So this is the third straight example for the Fibonacci series. In the next class we will discuss the next topic.